So good afternoon for those in Mexico and good morning to us in Australia in Brisbane. And welcome to the third day of this online conference, which is exchanging experiences in conservation between Mexico and Australia. And I hope you've had a great couple of last days. I think it's a really clever idea to have like a conference an online conference split across 3 days, but having short sessions. And today we've got 5 talks, and then we're going to end with a discussion. So first of all, I'm just going to introduce Steve. So we have Tatsuya Amano from the University of Queensland, and he's going to talk about language barriers in biodiversity conservation. What are the consequences and the solutions? And so Tatsuya, he's currently the Deputy Director in Research at the Centre for Biodiversity and Conservation Science. And he's interested in using scientific information for biodiversity conservation, and his research is focused on identifying gaps in information and their drivers, overcoming information gaps with modelling approaches, and bridging the research implementation gap. He also leads the Translate project, and that stands for Transcending Language Barriers to Environmental Sciences, which is an Australian Research Council project, and it's basically trying to incorporate those aspects that he mentioned to understand the consequences of language barriers. So would you like to start, Tatsuya?
Yep, great. Thanks very much, Valerie, for the kind introduction. Can you hear us all? Sorry, can you hear me all? Can you hear me?
Yes.
Good. Yep. So, shall we start? It is my great pleasure to meet you all at this conference and also be giving this talk at this conference. And my name is Tatsuya Amano, and I have a wide interest in conservation in general, but I'm particularly keen to facilitate the use of scientific evidence in conservation. And related to this, I've been leading this project called the Translate project. So there's a URL here, so please visit our website. And I've been leading this project and investigate consequences of language barriers in biodiversity conservation. So that is the focus of our project. So in this presentation, I will give you an overview of our project's outcomes so far. So I will start with why language matters in biodiversity conservation. So here, the map on the left shows the countries where English is the first language. The map on the right is the distribution of threatened species. And as you can see, 2 very contrasting maps. The regions where biodiversity is the richest and is threatened the most, and therefore conservation is needed the most, are often regions where English is not widely spoken. And this obviously includes Mexico. And when tackling the biodiversity crisis, the key is to involve and engage people, because those people quite often cause the issues, but also have a potential to solve the issues. And those people, especially in biodiversity hotspots, use a wide range of languages, over 7,000 languages, to communicate. So to me, it only seems natural and absolutely necessary to consider how having so many languages among us might affect our understanding of what is going on around the world. And that's why our Translate project has been investigating the many consequences of language barriers in biodiversity conservation, focusing on these 3 different aspects. More specifically, in this paper, we showed that up to 36% of scientific documents on biodiversity conservation appeared to be published in languages other than English. But such non-English language scientific evidence is likely underused in the global level synthesis of evidence because it's not readily accessible. So this is the language barrier to the global synthesis of evidence. And then there's another type of language barriers where scientific evidence available only in English is not effectively used in the local application of scientific evidence, such as local decision-making in countries where English is not widely spoken. And finally, because of the language barrier, non-native English speakers may not be able to contribute to the generation of scientific evidence. So this is the language barrier to the generation of evidence. So in this talk, I will introduce some of our works on each type of language barriers in science. So first, how is non-English language science used in global evidence synthesis? We looked at the proportion of references cited in these 8 international assessments on biodiversity by language. And not surprisingly, English language references dominate in most assessments, on average, 96% of the references cited being in English. And this is in clear contrast to the result we saw earlier, that 36% of existing conservation literature was written in non-English languages. So this indicates that most of the existing non-English language science is not being used in global level evidence synthesis. So next, what are the consequences ignoring non-English language science? In this paper, we conducted comprehensive searches for non-English language literature on conservation. The Conservation Evidence Database stores English language studies that test the effectiveness of conservation actions identified based on a set of selection criteria. So our project has used the same criteria to identify relevant non-English language studies. And we identified over 1,000 non-English language studies that provide evidence on the effectiveness of conservation interventions, compared to over 4,000 English language studies at the Conservation Evidence Database. We have also identified 466 journals in 19 languages, including many from Mexico, including this journal, some of which have been publishing papers since the 19th. So we can at least say that by ignoring non-English language science, we could be losing access to this amount of scientific evidence. And many people often assume that such non-English language studies are become increasingly globalized. But in this study led by Sean Chaudhry, we showed that the number of publications on biodiversity conservation has actually been increasing in most languages, especially in Spanish, Portuguese, simplified Chinese, Russian, and so on. So contrary to a common perception, the importance of non-English language knowledge in conservation is certainly not diminishing yet. And another problem is that ignoring non-English language science causes biases in our understanding of biodiversity. In the research area of healthcare, it has been shown that more statistically significant results are more likely to be published in English. So this issue is known as bias in evidence synthesis, more specifically language bias in statistical results, meaning that the nature and direction of a study's results can affect what language it is published in. And we found language bias in statistical results in conservation too. In this paper, we showed that effect size was hugely different between English language studies and Japanese language studies, although all these studies were used in the same meta-analysis. And in this case, ignoring non-English language studies would bias the conclusion of meta-analysis. However, a slightly different type of language bias might also exist, especially in ecology and conservation, which is language bias in study characteristics. For example, studies conducted on a local species might be more likely to get published in non-English language journals, as those studies would not be of high interest to international readers. In their recent work, we showed that language bias in study characteristics does exist in for evidence synthesis. So these blue grid cells show the distribution of English language studies testing the effectiveness of conservation interventions stored in the Conservation Evidence Database. And you can see that English language studies are, not surprisingly, concentrated in certain countries such as the UK and the US. And there's a huge gap in the availability of evidence in other parts of the world, including the most biodiverse regions such as Latin America, Africa, and Asia. And now, when we searched non-English language studies testing the effectiveness of conservation interventions, we found a number of relevant non-English language studies in those regions with little information based on English language studies, such as Latin America, Russia, and East Asia. And those non-English language studies often provide unique evidence on the conservation of threatened species. Examples include a Spanish language study on endangered Andean mountain cats in northern Patagonia, and a Japanese language study on endangered Blakiston's fish owls. So this clearly indicates that by ignoring non-English language studies, we could important scientific evidence for those areas and species with little or even no English language evidence. Okay, so let's move on to language barriers to the local application of scientific knowledge, another type of language barriers. First of all, how is evidence made available in different languages used in local decision making? For this, we identified national reports on the state of biodiversity countries where English is not an official language and looked at the proportion of reference cited in those reports by language. We are actually surprised at the very high proportion of non-English language references in most reports, shown in yellow and orange here. Across those 37 countries, 60% of references cited was, on average, in a non-English language. And as you might remember, this is a stark contrast to the international assessments, where only 3.4% of the references were written in non-English languages. So this means that by ignoring non-English language literature, international assessments may overlook important knowledge on local and national biodiversity. And this high proportion of non-English language references in national biodiversity reports is partly due to report authors recognizing the importance of non-English language scientific evidence. For example, when we surveyed those report authors, 75% of them answered that they cited non-English language papers because they are indeed relevant to their reports. In contrast, only 25% of the report authors answered that they cited non-English language papers because they were easy to understand. This clearly indicates that in those countries where English is not an official language, non-English language literature is being used because they indeed provide relevant evidence and not because they are just easier to understand. We also asked those report authors how English language barriers might have impeded the use of English language literature in their reports. And a quarter of the report authors answered that they struggled with understanding English language literature when writing their reports. So this indicates that language barriers indeed pose a serious barrier to the uptake of scientific evidence that is available only in English as well. Okay, so lastly, let me also touch on language barriers to the generation of science by non-English speakers. Because science is now conducted largely in English, especially at the international level, non-native English speakers can face multiple barriers when conducting different types of scientific activities in English, such as paper reading, paper writing, paper publication, and research dissemination. So we tried to quantify these barriers for non-native English speakers by comparing the amount of effort needed to conduct different scientific activities in English between non-native and native English speakers. And for this, we surveyed 908 environmental scientists from those 8 countries. And what we found was striking. When comparing native and non-native English speakers with only one publication, our survey shows that non-native English speakers need 91% more time to read each paper in English. So this means that their hurdle is twice as high as that of native English speakers. Then they also need 51% more time to write each paper in English. And before they can submit, they still need to ask someone to proofread their English for most of their papers. Even then, their papers are more likely to be rejected simply due to their English writing. And the frequency is 2.6 times higher in non-native English speakers than native English speakers. And there's also a huge difference in the frequency of language-related review. Non-native English speakers are requested to revise their papers 12 times more often than native English speakers. When preparing an oral presentation, they also need 94% more time than native English speakers. And what's more, 30% of them often decide not to attend an international conference, and half of them decide not to give an oral presentation due to English language barriers. And it's not the end of the race. As long as you are in a research career, you will face those barriers every time you do any of these scientific activities. So it's clear that these disadvantages can impede the participation and career development of non-native English speakers in science, seriously impeding their contribution to the generation of scientific evidence globally. So now that we all know language barriers can have serious consequences for conservation and science in general, the question is how we can solve these problems. I'd say it's not easy at all, and we definitely need a concerted effort at every level, from individuals to institutions and society. So in this article, we compiled 10 simple tips for overcoming different types of language barriers in science. So let me show you a few examples. First, disseminate research in multiple languages. Some academic journals now encourage their authors to provide abstracts in non-English languages and also write a blog post on their papers in other relevant languages. And it seems that providing a non-English language abstract does help decision makers. In our survey with authors of national biodiversity reports, almost half of the authors reported that having non-English language titles and abstracts would help them search and understand English language literature. Next, make sure to use knowledge sourced from multiple languages. Of course, this depends on the focus of your activities, but if you are working on issues that occur across multiple countries, never assume that all relevant information is available only in English. One simple solution is to find collaborators who are native speakers of different languages, just like we did for this study. So we collaborated with over 60 different people from around the world for this study. So today, science is hugely globalized. So finding native speakers of, for example, Spanish, Portuguese, French, and Chinese within your network is not that difficult. So this also highlights the importance of developing culturally diverse environments in academia. We need a diverse range of people to make the best use of knowledge that is available from around the world. You also need to use appropriate literature systems to find non-English language literature. For example, you can use Google Scholar, which covers pretty much any language, and local literature search systems that are specific to each language. We have also compiled a list of 466 peer-reviewed non-English language journals in ecology and conservation. Box 1 of this paper also provides some practical suggestions, so these should be a good starting point. Things to do in order to overcome language barriers for non-native English speakers. A small number of journals already provide very good English editing support for non-native English speakers, so we should definitely expand such efforts to many other journals. And some conferences have also recently started to provide support for non-native English speakers, such as allowing multi-language presentations or offering mentoring systems where non-native English speakers can receive support for presentation preparations. And I see this conference is also using some tool to overcome this problem, so that is great. So quite often we blindly assume that everyone needs to speak in English at international conferences, but this example nicely illustrates that there are still so many things we can do to support non-native English speakers and increase the diversity in scientific communities. And related to this, just recently, the journal Science declared that they will use of generated by ChatGPT or any other similar AI tools. However, of course, ChatGPT and many other similar AI tools can provide very useful and importantly, free or affordable English editing services for non-native English speakers. And this is particularly important in terms of achieving equity in science, because as our recent work showed, researchers from lower income countries can't afford services and are therefore disproportionately disadvantaged by this policy update. So clearly, Science's updated policies reflect a biased native English speakers-oriented view of the use of AI tools in science. So we immediately wrote a letter to Science, led by Violeta Verdejo Espinola, explaining how these AI tools could help to achieve better equity in science. And good news is that in response to that letter, the journal has announced that they recognize potentially acceptable use of AI tools and may consider adjusting the updated policies in the future. We still need more voices to change their policies, but this example clearly shows that many journals still don't provide genuine support to non-native English speakers, and we need a concerted effort to change this situation. Okay, so that basically concludes my talk today. Thank all the collaborators of our Translate project for the truly huge contribution. So we are still working on many other exciting research and solutions. So please do visit our website here. And if you are interested, contact us anytime. Let's work together to solve this important challenge in conservation and science. Thanks very much for listening. Thank you.
Thank you, Tetsuya. That was really some important findings which are relevant to all of us who are trying to learn and build from previous research all around the world. So we have time for just a couple of quick questions. We have a question in the chat from Elvia. How can organizations, institutions, and governments interested in conservation promote the preservation of Indigenous languages in the context of biodiversity conservation, preventing these languages from being lost along with the natural wealth they protect?
Yeah, that's really definitely important point. So obviously the distribution of languages and the distribution of biodiversity is hugely overlapped. And obviously there's an important role of indigenous knowledge, local ecological knowledge. So conserving those languages and cultures, associated cultures, is definitely important for biodiversity conservation. So there are just so many things we can do, but I think one important thing is to recognize the important link between languages and biodiversity conservation. So this is quite often overlooked. So recognizing the link between those two might be the first step towards the conservation of these two, different components of diversity.
Yes. Is anyone else have a question? Okay. Thank you.
There was another question in the chat.
Is there?
Oh yeah, there's one question.
Oh, down the bottom? Okay. Yeah. What are the long-term effects of not addressing... Oh, no, that's the same one. Oh, no, same. Oh, some from Elvia as well. Sorry. What are the long-term effects of not addressing language barriers in biodiversity conservation, not only in terms of the loss of knowledge and community participation, but also in the ability of conservation initiatives to succeed in protecting vulnerable ecosystems?
So, yeah, I'm not sure if this is the long-term effect, but essentially, it's essential in conservation, to facilitate the knowledge to local communities. It is essential to understand the language barrier, and it is essential to overcome language barrier. But also, it's important to obtain unbiased knowledge at the global scale. So in those two ways, I think it's critically important to overcome language barriers. But I'm not sure if this answers this question, but hopefully.
Well, perhaps we can chat about it again at the end of the discussion.
Yeah,
So yeah,
definitely.
thank you again, Tatsuya. And
Thanks
now
very
we
much.
have,
Thank you.
thanks, Hebrain Perez Mendoza. So if you'd like to share your screen. And the talk will be about assessments to protect overlooked species programs of actions for species conservation, looking at case studies of alligator lizards and rattlesnakes. And so Hebrain's research focuses on amphibian and reptile ecology and conservation, using demography and life history evolution to transcriptomics, which hopefully he'll be able to explain. On this wide array of approaches, he had the opportunity to participate on the creation of the programs for species conservation for rattlesnakes and alligator lizards, and he collaborates with several groups around the world, and he has been president of the Mexican Herpetological Society for 4 years and previously was the vice president for 2 years, and he's currently also the president of the Evolutionary Demography Society.
Thanks for your kind introduction, Valerie. Just give me a minute to have, yeah, I think it's ready, the presentation. Can you see it?
Yes, we can.
Great. And can you hear me properly? Yes.
Yeah,
I hope so.
no, you sound
Okay.
good.
So I will talk about the assessments to protect overlooked species, specifically with the programs of actions for species conservation, which is a tool that we have developed on Mexican laws. And I will speak specifically of the case of alligator lizards and rattlesnakes. And to do so, I would like to start recognizing the big challenge that represent working with this kind of species, because usually when you work with conservation, most people is focused on big mammals or birds of prey or this charismatic or emblematic species. But many times we have overlooked these small species or species that have been demonized somehow by religion. So as it happens pretty much in every country in the world, amphibians and reptiles are usually overlooked on the protection programs, despite the fact that they are the most threatened species among vertebrates. And also, most protected areas are not designed to favor small species connectivity, such as amphibians and reptiles, or even distribution coverage. And what I'm trying to say here is that usually we think on conservation areas design in order to achieve protection for these species that have like really big home ranges or that have abilities to move around the landscape in a different way that most amphibians and reptiles do. So we have like this mismatch in species protection, considering the mammals or vertebrates like bats or birds, and the other end of the spectrum are these small species with really small home ranges and really low capabilities to move throughout the landscape. And this is kind of weird because when we see our flag, we see there's an eagle and also a rattlesnake. But most people think that the emblematic species that we see in our flag is the eagle. And that happens with a lot of countries. Actually, if you see the flags from several countries, they have birds of prey. And it's really uncommon to have a species like reptiles and amphibians. Next slide, please. But what happened with our culture? Because this is also a problem of perception. How do we see the species that we're trying to protect? And here we have to deal with the idea that usually in several cultures around the world, actually, the snakes have been seen as gods. And just the idea of the Judeo-Christian religions have considered the representation of the devil or demons or evil in general. But if we see in our culture and other different cultures, the snakes represent infinity, immortality, renovation, vital energy, and for some other cultures, they represent death. And this is really associated with the capability of most snakes to shed their skins in a complete way. So if you have seen a snake that it's just about to shed the skin, they have this grayish color, their skin, but as soon as they start showing their new skin, they're really brilliant. So it's brightful, colorful, and a lot of people think that this represent renovation. So we've seen this in representations from all different cultures, from Mesopotamia, and even here in Mexico, the goddess Coatlicue represents fertility, and it has this skirt made of snakes, of rattlesnakes specifically. But it is also present in another cultures, mainly in Southeast Asia, when we can see the representation of the king of Nagas protecting Buddha, or the Prince Siddhartha, when he was trying to reach the path to illumination. And the king Naga protected Siddhartha, the Prince Siddhartha, from the monsoon. And it spread the hood in order to cover and prevent it from get wet. But also in the Egyptians, you can see that the snake figure represents the idea of the fight between the night and the day. And actually, the goddess of snakes in Egypt represents the idea that it eats the sun every night. So it's the struggle between the night and day. And in Mesoamerican cultures, it's present pretty much everywhere. And Quetzalcoatl or Kukulkan, it depends in which culture do you represent it. It is like the main god of these cultures. So why did we lose the perception that snakes are like a good thing in our environment and start to represent them as demons? So we have to recognize that Mexico, it's rattlesnakes land, because from this 56 species of rattlesnakes, 47 are distributed in Mexico, and several of them are endemic to Mexico. Actually, we are considered the country of the origin center for diversification of rattlesnakes. And approximately, because we know probably this bad look or bad perception is associated with the fact that these are venomous species that may cause death if they're not treated properly, the bites. And in Mexico, we reported about 200 bites per year, but only 45% are caused by rattlesnakes. Most of the bites in Mexico are caused by another viperrid species, which is named Naujaca. It's the common name, but it's from the same family, but from a different genus. And this is also interesting that most of the bites are usually on the upper limbs during the rainy season, which means that most of the bites occur because of bad handling. Because otherwise, you would expect that these species that are mainly around the grass or on the soil would bite the legs, but that doesn't happen. And that means that usually bites occur because people try to catch the snakes or move the snakes with their hands. So most of the accidents occur on the upper limbs. So we start working with these ideas of how perception of these species work on the community, and we started making a poll on the internet and asked people what do they think about rattlesnakes in general, and if they consider that they're dangerous, venomous, or even deadly. So we identified that a lot of people have these misconceptions about snakes, and we also start looking for which are the main threats that rattlesnakes face on Mexico. And it really changes when we see throughout Mexico, because in northern Mexico that we have most of the biggest species of the genus, on those places, the intentional killing or direct killing is the main threat, because people see and they try to kill the snake. They basically said that the only good snake is a dead snake. But in central Mexico, for example, we have like a different threat, because most of the species from the mountain regions of central Mexico are really small size. So people didn't even notice that they're there. But as these species occur on pine and oak forests, these sites are really attractive for house developing, and mainly for like really nice houses. So these developments have the land use change is the main threat for those species in central Mexico. And in southeastern Mexico, we have a completely different problems, because most people kill these snakes because they use it on traditional medicine, and also because of the perception that they're the representation of the demon. So when we look at the threatened status that IUCN and the Mexican laws give to these snakes, we see that only around 22 to 27 species have been assessed. And then we decided to do an assessment for all the genus in order to have a full coverage and a better understanding, because they face the same threats, even though that there are different species, because most people consider that rattlesnakes are like the same. It doesn't matter if it's a small species or a big species. And you're seeing on this picture an specimen of Crotalus transversus, which is a really small-sized rattlesnake, which inhabits in El Ajusco, in central Mexico, and only there. And I just put this picture because it is interesting that for the IUCN, this species is considered as least concern, because it occurs in a protected area, but we know that that doesn't mean that they're actually protected. And under the Mexican laws, is considered endangered. So it is like a huge mismatch depending on which laws are you following to consider the threat level that species have. So we decided to do like a full assessment of the genus, and with that work, we worked on the this program for the conservation of species for the rattlesnakes in Mexico, which is a document. We received funding from the CONAMP, which is our Natural Protected Areas Commission, and from Semarnat, which is the Secretary of Environment. And with that, we start working with each species on the genus distributed in Mexico, and we assess different, we assess the threats that they are facing. We also estimated their distribution in order to know how big or how small and how microendemic or not are the species. And following the guidelines that the Mexican laws establish, we do this assessment. We did this assessment. And we established some specific goals within the limited time frame. So the main problem that we saw is that and I hope that most people around the world understand this, because I hope that we all share this problem, is that several governmental agencies or different government programs look for different things. So the problems that we're facing is, for example, the Secretary of Agriculture provide money in order to promote land change use for agriculture or for raising cattle, as for example. And that means that we're losing a lot of places that these species can be distributed. And when we speak about amphibians, for example, the main problem is that this secretary just use fishes, exotic species of fishes, in order to provide to the people with food, but people doesn't use that food because they're not used to actually use it as their main protein source. but also we're losing our native species because these species became invasive. So our first goal was to actually promote a different several talks and programs to talk and reach all the stakeholders from the different agencies of the government to actually reach an agreement in order to say, we're looking for this, which means the protection of all these species, but we need your help to start stopping these activities in these areas. And we also identified some areas that are more important because they have more diversity or because it represents some corridors for connectivity and allow gene flow. And the other thing is that these species are facing a lot of illegal trade. And this is because many people like to have venomous species in their houses. I don't know why, but they found them attractive. And this is like a huge threat for the species that inhabit the peninsula of Baja California. So the other thing that we realize is that we need to provide with capabilities to the people on the border and in customs in order to recognize the species and know if they are protected or if they're not. So we also work with some scientific sectors in order to provide these guidelines to recognize the species for this personnel. So this was the huge task that we have to take for the rattlesnakes. But for alligator lizards, we faced like a different problem. And this was completely different because with rattlesnakes, a lot of people like to work with this species. And there's a lot of information of this species because, as I've told before, is a lot of people found them fascinating, or even the fact that they're venomous is attractive for them. But the case of alligator lizards is completely different. These lizards are arboreal lizards, and most of the time they spend their time on the canopy. So they're really hard to see. And that's the first problem that we face with this species. And the other thing is that they inhabit mainly in cloud forests, where the visibility is less because of the fact that we have missed most of the time at these forests. So these species are distributed among 1,600 and 2,600 meters above sea level. Most of the species, we have some species that inhabit tropical forest from 200 meters to 1,600 meters above sea level. And the other thing is that they're demographically rare. So the fact that they inhabit the canopy and that they're demographically rare makes them really hard to study. So we started this project working with the species that we're seeing in the picture, which is Abronia graminea. This species inhabits in the border of Puebla and Veracruz, in the cloud forest of the Acultzingo, Cumbres de Acultzingo. And we start working with this species because it's the most abundant. So it's the species that we can actually sample in the field and follow for several months in order to know the schedules of survival, reproduction, and fertility in general. So we start following that population and realize that this species face a complete different problem because, as you can see, this is a very beautiful colored lizard, and they're not venomous, but the people from the local communities think they're venomous. They actually call them scorpions because they think that they're venomous, but they're not. So Mexico is also alligator lizard land because there's 38 species, and 27 of those species occur in Mexico. The other species are distributed along Central America. They reach to Costa Rica and El Salvador, but nothing more than that. So they're mainly from Mexico, and all the species have really small distributions. They distribute in this cloud forest, and they have really small size ranges, which makes them vulnerable to land use change. And the other thing is that the coal production in Mexico, in central Mexico mainly, it's a huge economic activity. And they usually, and you can let me lie about this. Most of the coal that you buy for doing carne asada says or states that it's made from oak. So most of these species are distributed in these oak forests. So a lot of these forests are used to coal extraction. So that's a big problem. And the other problem that we face is that due to their look, all species are used on pets market. However, most individuals are extracted from their natural habitats because they're really hard to raise under housing conditions. So one big problem that we looked with this species is that most of the specimens are shipped to Germany, and they end on this Terraristica Ham, which is like a huge fair for they sell all kind of reptile species, and yeah, it is the world's biggest reptile fair. But as you can see in this Mongabay article, it is also a hub for traffickers because people send them illegally from Mexico. They reach to Italy, and then somehow they get legalized. So these species are sold legally in Germany, but they are trafficked animals. So different NGOs work following the path of how this is done. And we start working with this assessment. Also, as I told you with the rattlesnakes, I'm going to go faster because I'm consuming all my time. And we also propose these different goals to achieve. And we realized that some of the specimens can be identified due to the patterns of their throat scales because they are unique. It's like a fingerprint. And we're trying to use this as a way to identify those specimens raised from captivity from those other specimens that came from the wild. And the achievement that we have with this project is that after our assessment, all Abroni species are now listed on the Appendix 2 of the CITES, with the exception of 5 species that are listed on the Appendix 1, because we tried to reach the people from El Salvador and Guatemala to propose this in the CITES meeting, but they decided to do their own assessment. So we presented the assessment for all the other species, and now they're all included in the Appendix 2. So now the traffic of these species around the world is illegal. So thank you so much for listening to me, and I'll be really happy to answer any questions you may have.
Thank you so much, Ibrahim. That was, yeah, an excellent talk. I could listen to you all day talk about Mexico's rattlesnakes and lizards. We just got a question from Elvia. What is the role of genetic research in the conservation of rattlesnakes, and how can it help protect these species?
I think we have like a lot of things to do with rattlesnakes because we have to recover the original knowledge about this species, because there are several documents that states that rattlesnake species were used from pre-Hispanic communities to avoid the loss of the cosechas of the crops due to the action of rats, and they use rattlesnakes to control the populations of rats. And even nowadays at the state of Morelos, they have like these practices, but they have been lost around Mexico. And the other thing is that we have to also tackle these problems with illegal traffic, because a lot of people from the US go to Baja California to extract some of the individuals, mainly of Crotalus anankelensis, Crotalus ruber, because these species are like pretty rare, and the collectors love this kind of rare species. So I think we have like a lot of things to do with this species, but I think we have some other species that also require a lot of attention. So I think that in order to actually understand the role that these species play on the environment will allow us to actually appreciate their ecosystem services that they provide to us.
Okay, thank you again. There are a few questions coming through in the chat, but unfortunately we have to keep on going. So I'll park those for the discussion, and I'm hoping that you are able to stay until the end.
Yeah, I'm really sorry I will not, but you can contact me on my email and I'll be happy to answer any question you have. Thank you.
Okay, thanks. So now we have Professor Jonathan Rhodes from the University of Queensland, and he's going to talk to us about landscapes for biodiversity and ecosystem services. So now we're going to go from rattlesnakes to mathematical models, and Jonathan applies models and decision analysis to inform environmental decision-making and policy setting, particularly for conserving biodiversity and ecosystem services. And his work has revealed new insights into how dynamic landscape change and climate change drive biodiversity and ecosystem services, and also looking at uncertainty under environmental decision-making. He's also worked on optimal monitoring problems to quantify the benefits of investment in new information and research for environmental decisions. And his work is multidisciplinary, and he applies his work across a range of scales from local to global. And his current work focuses on linking processes across global and local scales to inform environmental policy. So thanks, Jonathan. You want to share your presentation?
Thanks, Valerie, for the introduction. Yeah, let me just see if I can share. Can everyone see that? Okay.
At the moment, it's just your home screen.
Yep. Okay.
You just need to put it in presenter view.
Yeah. I'm getting there.
Yeah.
Okay, how's that?
Yeah, that looks great. We can hear you.
Excellent, great. Well, thanks, Valerie, for the introduction, and thanks also for the invitation to talk at this really excellent event. I think it's really fantastic initiative. What I will do today, I think, is in the spirit of really just exchanging ideas. What I'm going to do is basically give you a bit of an overview of some of the work that we do, and you know, if any of this interests anyone, I'm really happy to talk more about potential collaborations. So I think what I'll do is I'll first give a little bit of an overview of the work of my group. And then I'm going to talk about, I guess, three aspects of things that we've worked on recently, and one is really around you know, sort of landscape heterogeneity and socio-ecological opportunities for conservation. And I'm going to, in each of these, I'll show some examples of our work, draw on some examples. I'll talk a little bit about, secondly, about ecosystem services and landscape structure. We have a real interest in how the structure and change in landscapes drives ecosystem services and the benefits people get from nature. And then I'll talk very briefly about and just mention really some of the work we've been doing or starting to do over the last couple of years on thinking about how we link global and local interactions for policy and decision making in the environment, and particularly conservation. So my group's called the Sustainable Landscape Group. We sit within the Centre for Biodiversity and Conservation Science and at UQ, and we work primarily on applied problems really related to biodiversity, sustainability, and ecosystem services. We're a very quantitative group, so we use essentially models, usually spatial models, to try to model systems and ask questions about policy making and decision making. And we often couple that with formal decision science and where we can start to look at trade-offs between things like the environment and the economy and social factors and so on. And really our goal is really to create new knowledge to really influence policymakers and management decisions, really for sustainable landscapes. So that's sort of, and our link to our groups there if you're interested in learning more. So the first thing I wanted to do was talk about the work that we do around socio-ecological landscape heterogeneity. So if people force me to say what I do, I'd say I'm a landscape ecologist and have had a long history of working in ecological interactions across landscapes, but more recently been very interested in social and ecological interactions and social variability, because I think that drives a lot of decision making and opportunities for conservation. So one body of our work is really thinking about how do we start to bring in some of these social constraints and opportunities into both planning for conservation, but also for assessing policy effectiveness and what are the effects of these on policy effectiveness. So I'm just going to give you two examples of some of this work. So I've worked a lot on koalas in my time. If you're not familiar what a koala is, they're an arboreal species, live mainly on eucalypt species, eat the leaves. They're distributed across the eastern coast of Australia, and are a threatened species. Threats driven largely by things like land clearing, urbanization, and so on. Threats you would imagine. And so these couple of examples are using the koala as a case study species, but really tackling problems around how we manage largely private land and the policy and effectiveness of policy for koala conservation. So this first example is focused in New South Wales. So hopefully you can see my cursor. I'll see if I can get another moment. See if we can get my cursor up. Can you see that? Hopefully. And if you look at the map of Australia, this is based in New South Wales and the coastal region of New South Wales. And in New South Wales, that state, they have the state government have an organisation called the Biodiversity Conservation Trust, and one of their programs is to incentivise landholders on private land to protect biodiversity. And they run these programs, these tenders or reverse auctions, where they invite landholders to bid in terms of the price they would be prepared to accept to protect biodiversity on their land. So they run these tenders, and then the successful landholders are paid a financial payment to protect biodiversity on their land as an incentive, and then they're legally protected on their land. But there's really strong heterogeneity in landholder stated willingness to engage in this process, but also the bid prices they're willing to accept to give up some of their land for conservation, but also strong heterogeneity in future climate change. And this map on the right is some of the work we've been doing on trying to map that variation in social preferences by landholders. So what we were really interested in here was, given this program by the Biodiversity Conservation Trust, how does this social spatial variability in landholder preferences drive the effectiveness of these tenders? And one of the decisions that the Biodiversity Conservation Trust need to make is where to implement these tenders. So what we did, we built some models of this variation in spatial factors plus climate change, and then used conservation planning tools to prioritize locations for these tenders. And we did this across a number of different, hang on. Starting to move forward now. Oh, there we go. Okay, so and we did this across different scenarios. We had one scenario where we ignored both climate change and landholder preferences. Two scenarios where we had either considered climate change or landholder preferences, and one where we considered both. And this graph just summarizes some of the results. And I should point out, this is work done by Brooke Williams recently. And this basically shows some of the results along the x-axis is budget investment, and on the y-axis is essentially the benefit to koalas. The two lines at the bottom here show, as you increase budget, the benefit if you just basically ignore the landholder preference stuff. And the two lines at the top are the outcomes if you incorporate those landholder preferences. So clearly, incorporating those landholder preferences in your decision making has a massive effect. The second thing to realize is that when you don't incorporate landholder preferences, there's very little benefit of considering climate change. That's only revealed once you incorporate those landholder preferences. So there's an interaction here between those, the effect of the information on climate, but also the information on landholder preferences. And then, the priorities for the locations for these, where they should implement these tenders, varies across these scenarios as well. So, the main take-home message from that is really these landholder preferences matter a lot, and we should be considering them in where we allocate these types of private land mechanisms. Okay, so that's one example. This other example was also another koala example. This is a assessment of a biodiversity offset policy. So biodiversity offsets are essentially policy mechanisms and regulatory mechanisms whereby when developers have an impact on biodiversity, they're required to essentially offset that or compensate that by creating biodiversity benefits elsewhere. And in Queensland, and if you look at the map, we're sort of moving a little bit north now, still on the east coast, map up on the top right-hand side. Southeast Queensland, Brisbane, where we are, is where I am, is sort of in the middle of that red box. And in Queensland, the Queensland government offset policy for koalas requires developers, for every tree that they destroy when they develop land, they need to replace that by planting 3 koala habitat trees. And developers can either choose to do that in 2 ways. They can either choose to do that restoration to compensate for the losses themselves and deliver that, or they can pay and make a financial payment to a fund. And then the state government makes the decisions about where to invest those resources to meet the offset requirement. And so, but what we don't really know is what's the effectiveness of these 2 different approaches. So on one hand, the offset fund and the payment into an offset fund could be beneficial because the state government then can act strategically to get the best biodiversity benefit. But on the other hand, the state government then take on the financial risk of being able to deliver those offsets. And there could be a risk that they have insufficient funds to cover the offset requirement. So we're interested in what drives the effectiveness of those 2 different approaches. And we hypothesized that either it could be patterns of land use change. On the map here are some models we developed on potential land use change and loss of habitat over the next 30 years, or it could be related to the availability of offset sites. In this region, the availability of offset sites could be constrained, and these are sites where you could do restoration for a number of reasons. There's a lot of competition for land in the region, so accessing land to do restoration could be difficult, but also ecologically suitable sites might be hard to find as well. So there's social and ecological factors that might affect that availability. So what we found basically was development scenarios actually didn't matter very much. Land use is fairly constrained in the region, and capacity for very different outcomes in terms of development, given the amount of land needed for development, isn't great. But the availability of offset sites matters a lot. So if you look at this graph on the left, just look at the blue and the green lines. The blue line is basically the outcomes for when developers deliver the offsets. In this case, the developer has to deliver the required offsets, and this blue line shows basically as % of offset site availability changes, what's the change in on the x-axis, and then the change in total habitat area on the y-axis. So as you can see, that is very invariant to offset site availability, because developers really have to find those sites and whatever the cost have to deliver those offsets. The green line, however, is the offset fund scenario. And as you can see, when offsets are highly available, that does a lot better because state governments can act strategically. But when offset site availability is very low, basically it drives up the cost of delivering those offsets. And because of that, the offset fund no longer has enough funds to deliver those offsets. So you tend to do worse. So basically the offset fund performs well on the up, provided there are a wide range of offset sites availability. If offset sites are hard to find, it performs very poorly. So this has really implications for policy design. So that's just a couple of examples of that sort of work, thinking about socio-ecological landscapes. In related work, we're also interested in the structure of landscapes and ecosystem services. And so for those of you who are not familiar with ecosystem services, basically ecosystem services are the benefits, things like wood, food, spiritual connection and so on that people get from natural systems, sometimes called nature's contribution to people, which is an analogous term, and really depends on 2 things. One is the sort of natural capital we call natural capital. So these are the natural systems that provide the the processes and capital that can provide a potential ecosystem service, but also depends on the demand for that service, the beneficiaries. Who are the beneficiaries? What do they demand? And so it's the interaction between this natural capital and the beneficiaries, what we call supply and demand, that really drives the generation of those benefits. And these can often depend on other things like other types of capital, like manufactured capital, social capital, other infrastructure and financial capital. So you might need, for instance, if you're growing crops, you might need to add fertilizer, for instance, to benefit from the ecosystem service of the soil, or you might need infrastructure to harvest that crop. And it also depends on the governance and social context. And the other thing it can depend on is really that spatial interaction between where people live and where natural systems provide that service. So because the flows of benefits can depend on those connections. Think about people visiting parks or flows of water across landscapes. So we're really particularly interested in the structure of landscapes, how that interacts with these other types of factors such as governance and social context. So what we have found, and this is sort of work that we've done with Jean-Paul Metzger and Jarima Villarreal Rosas, who many of you know because she's helped co-organize this event. But the work we did, this has really shown that in assessments of ecosystem services, those studies largely ignore the spatial configuration of sort of demand and the social aspects of ecosystem services. So there seems to be a big gap in terms of being very explicit about how so the structure of social ecological landscapes actually drives ecosystem service benefits. And then Jarima's work in a similar sort of goals, but really in thinking about conservation planning. And so she did a review of the conservation planning literature, looking at to what extent studies actually were explicit about the social and demand side of ecosystem services, and again identified a big gap in terms of the consideration of those factors. And so we've been quite interested in thinking about how landscapes drive the interactions between the social and ecological components, how that leads to particular outcomes for ecosystem services, and then what does that mean for policy and planning. So this is just, again, a couple of examples of this type of work. So this is work we did with Matt Mitchell. This was a study where we were interested in thinking about the effect of landscape fragmentation on ecosystem services, and really are trying to ask the question, if we think about the effect of fragmentation on biodiversity, often considered to be, this is debated, but often considered to be fragmentation bad for biodiversity. And so what we wanted to do with using some simple models, ask, well, what might happen if we think about the spatial interactions between natural areas and where people live in a landscape, and how that might structure in a landscape? Do we still get the same sort of patterns as we would for or relationships between fragmentation and biodiversity for ecosystem services? And what we show is that we even if you assume that fragmentation is bad for biodiversity or the supply of the service, you can get these sort of compensating effects where intermediate levels of fragmentation are optimal for ecosystem services. And this is really because fragmentation puts people in closer contact at the interface between nature and people. And then again, Jarima's work, she had done also some work following on from her review work, looking at and this is the an area in the Brigalow Belt in the map here. You can see the gray area. I think John Dwyer talked about that yesterday. He was talking about restoration, but also long history of habitat clearing there. And Jarima really modeled the effect of that clearing from 2002 to 2015 on flood risk for people. And find that across different sectors, and that the graph on the right shows the impact of that clearing on flood risk for food, rural and urban residents. And as you can see, quite different effects. And this depends on the spatial relationship between where these different sectors are located spatially and where the clearing has occurred. So this has really important implications for both protection of habitat and forest, but also restoration. And then very quickly in my last minute, because I know I'm about to run out of time, the work we're currently doing is really trying to link these sort of landscape scale studies that we've done a lot of to interactions across large scales. And this is really in recognition that we're really highly connected globally through things like trade, information flows. You know, these sorts of events are connecting us. We also have flows of biological and physical material, flows of water, migration of species. International policy settings can connect countries. And we really focus using this sort of idea of telecoupling, whereby thinking about changes in social ecological systems in one place can affect other very distant socio-ecological systems. And we're interested in how we start to think about environmental policy and planning, taking into account these global to local spatial interactions. And we currently have a working group working on some of these things. We had a workshop earlier in the year, and we have a range of different projects around this topic, from looking at sort of impact of trade, local impact of trade, to thinking about, you know, local impacts of global conservation policies, taking into account these telecoupling processes and so on. Anyone's interested in that, I'm happy to talk about that more, but I'm not going to go into detail right now. Okay, thank you very much.
Thank you, Jonathan. That was a really great talk, especially since biodiversity is so closely linked to the provision of ecosystem services. We have time for a couple of questions, and there's some in the chat. So first from Elvia, what role do ecosystem services such as disease regulation play in preventing the spread of zoonotic diseases?
Yeah, look, certainly I think that things like natural areas certainly have a role in assessing the spread. So we've done some work in Brazil with collaborators there, looking at the spread of yellow fever and showing that the distribution of forests and roads and so on actually drives the spread. So I guess there's some so that and actually having more forests in the landscape prevented that spread. So yes, it certainly has an impact, and I guess there's probably trade-offs between these things in terms of other ecosystem services, or maybe win-wins in terms of ecosystem services and reduction of zoonotic diseases. But I'm not an expert on zoonotic diseases, so yeah, I've done a little bit of work in that space, but not much.
Okay, and another question from Pauline: is there a way to financially value the ecosystem services depending on the insurance costs of the different infrastructure at risk shown in that map?
Yeah. Yes, it's not something that I think I guess you're talking about Harimal's work on the flood risk. Yes, it's not something she did in that work, but I think you could, yeah, or the value of that infrastructure. But certainly, if you could get data on insurance costs, I think that would be one way to value it. Yep.
Yeah, and she also just asked what are the ecosystem services flows.
So this is in terms of the flood risk stuff. Is that right? Or yes, okay.
So the one that you should, yes.
Yes. So I guess the flow really essentially in that case is the flow of essentially water across the landscape. So we modeled the flow of water across the landscape, and that's influenced by the amount of forest cover. So that's the mechanism that connects the ecosystem service supply and to the demand, which is the infrastructure you want to protect. And the ecosystem service itself is the difference in flood risk with and without forest cover. So if you remove that natural forest cover, what's the flood risk compared to if you have that natural forest cover? Yeah, so that's how we did that.
Okay, great. Thank you for explaining that. Okay, now we have, we're going to move on, and we have Montserrat now, Suarez Rodriguez, again from the National Autonomous University of Mexico. And the talk is going to be on animal behavior studies in Mexico and their contribution to biological conservation. And Montserrat research focuses on the consequences of pollution and human activities on animals. And she uses behavioral and physiological responses of animals like fish, amphibians, and birds to explore how safe pollution levels, according to current regulations, may be causing damage to several animal species. And her research tries to create awareness of the negative impacts that concentrations of toxins and pollutants that are apparently safe for humans can actually have on other organisms. And so she's also interested in the interactions between native and invasive species of animals that may disrupt the functioning of native populations. So, and hopefully using this information as a basis to propose the changes which are required to current regulations of pollutants.
Hello, can you hear me?
Yes, we can.
Okay, thank you. Yes, I'm going to step here because I am too short for the podium. I'm sorry. But good morning in Australia. Buenas tardes a todos. Today I'm going to talk a little bit about my work, but more than that, I want to bring up a discussion that I realized that it's vigent. I didn't know about this discussion and I found it really interesting. So I changed a little bit my talk towards that discussion. So this discussion,
Montserrat, we can't see your face now. Oh, now we can. Yeah.
Yeah.
I think when you stand to the side, we just see your back in the.
My back. This camera. ¿En dónde me paro?
That's good.
I'm sorry, I'm too short for the podium.
Oh.
I am Mexican. I am a true Mexican in that regard. Is it? Yeah.
That's good. Yeah. Thank you.
Okay, so I'm so sorry.
Yeah.
I didn't know which camera. So I was saying that I would like to talk a little bit about my work, but I also want to bring up this discussion that goes around how animal behavior, or more like this question if animal behavior is actually valuable for biology conservation. So I found that this discussion on the literature where the idea is that biological conservation focuses on the population level. So if we think about it, animal behavior focuses more on the individual variation of within or among populations. So there is a discussion around it to discussing if it's actually valuable for conservation, directly for conservation. And if you are interested, I can direct you to that literature. But for now, I'm going to focus on one review specifically. And this is a paper that came around to 2011 from a group in Israel, where they actually tried to come up with a solution for this discussion. So they actually did a framework to try to help behavioral biologists to focus their research if they are interested in actually helping biological conservation. So they did this idea, they make this framework where they mainly focus on this that they call behavioral domains, that I would call behavioral groups, more than that. And these groups are actually behaviors that are centered in the success of survival and reproduction for animals. So it is moving towards movement, foraging, social interactions, and of course, reproduction behavior. And they go in 3 topics. So they suggest these 3 topics that behavioral biologists can assess to help with conservation, actually. So what I'm going to do is drag this diagram to all my talk. And I am going to give you some examples of what we do in my lab to kind of check if we are doing it well in this framework of conservation biology. So for me, the link between behavior and conservation feels natural because I am an ecologist focused on behavior, of course, animal behavior. And I like to investigate my questions through also mechanisms. But the most important part, I think, is that I like to assess these urban disturbances. So I am in that context. So for me, when I always, maybe I don't focus mainly on the conservation aspect of an animal, but I found that it is really important, the findings that we are revealing. So actually, this is the main theme that I am focusing in my work, that is the changes in response to human disturbances. And I have found that behavior is a fascinating way to actually study how the changes in environment affect behavior. And it's kind of cheap, so it's a good way of fast doing it and in a cheaper focus. So these changes in response to human disturbances, we mainly focus in this in search for information on how flexibility or the lack of flexibility of behavior puts at risk animals and animal populations, of course. So they talk a little bit about these disturbances, and those are topics that we have been discussing through all these talks. So it's something like fragmentation, pollution, alien species, and these that I found fascinating that are ecological types. For this part of the talk, I am going to focus on pollution specifically. So pollution is a topic that I am very interested in. We can find pollution in almost every environment. We have different residues from chemical pollution in the soil, in the water, in the air, but also we have different types of pollutants, like light at night or noise from urban sources. And for this part of the talk, I am going to talk a little bit more specifically about chemical pollution. So it is very interesting for me to find that chemical pollution keeps being a very important topic, because we now know that almost everything we manufacture can cause some type of chemical pollution. And because of this, we have made some efforts in the world to try to regulate at least the concentrations of these chemicals in different environments. I think the most difficult part is that oftentimes these regulations are made for human health. So those regulations are forgetting about all those other organisms that are not our size, not our physiology, not our behavior. And this could be detrimental for this species. Also, there is evidence in the literature or support for this new hypothesis that it has been called intermediate disturbance hypothesis, that it states that not the highest concentration of pollution, it's the most detrimental for organisms, or at least it's not necessarily the most detrimental for organisms. And there are support for this hypothesis. So this gives us the idea that actually the concentration of pollutants has not linear effects with the different effects, physiology, biology, population ecology with organisms. So what happens is that maybe organisms don't die, but they will have effects at longer term, and this will affect their fitness. So for this, I'm going to talk a little bit about this pesticide that I have been working on my lab, which is chlorpyrifos. Actually, Diego talked about this a little bit in his talk. But this is a very interesting chemical because it's an organophosphorus compound. But the most interesting thing is that many countries have banned this chemical. So they don't use it anymore. Actually, I was doing some research, and in Australia, it was banned in 2019. But in Mexico, it's legal. And actually, we keep using it in our crops. And for example, some countries like United States and China are banned. They don't use chlorpyrifos anymore, but they export the chemical to our country. So it's a double standard because they are not using it, but they are manufacturing and they are giving it to us, right? So it's those problems that we cannot achieve yet. So we keep using it. There are some reports about the safe also concentrations in our water bodies, but we keep having it. So what we have been doing is that we have been trying to test this chemical in this system that is Dryophytes arenicolor. It's a frog. What I find fascinating about amphibians is that they have to go through a metamorphosis. So they have a stage, and these frogs specifically have this stage of tadpoles where they are aquatic. But when they turn into frogs, they actually become terrestrial. So they are changing environments and they are changing exposure to different chemical pollutants. So what we did is that we have been doing is that we have been exposing these animals to different concentrations of chlorpyrifos. One is like the standard concentration that we can find in our water bodies, that they are supposed to be healthy for humans. And actually we are using a lower concentration from that. And we have been focusing on cognitive functions, foraging, and mobility, which are behaviors that are essential for success in the wild. So we expose these individuals during their stage of tadpoles, and then we also measure some things in the tadpole stage, but I am going to concentrate on the effects at adults. So what we have found is that these frogs that are exposed to these pollutants, they are less reactive to prey, and actually they are not that successful catching their prey. Also, they have shorter jumps that can tell us about the mobility of the frogs. And one very interesting thing is that they have shorter time of metamorphosis. So they are becoming frogs at a faster rate. And yeah, well, this is the jump, sorry. Also, we have been finding things in light pollution. It's something that I am very interested too. It works similar. We have found with the frogs that it works similar to chlorpyrifos in regards to how they behave, but in this case, frogs become more mobile, more active for some reason. And now we want to try to test different types of light, because in Mexico City, I don't know if you have noticed, but they are changing the luminaries at night. So we used to have this warm light, now they are changing it to LED light that is brighter and wider, more like this light that we have here. And we want to find out if this is going to be better or worse for animals. So in this second part, where I have this, now that we have all this information, they say that we should use it to come up with captive breeding and reintroduction programs that are actually focused on the behavior of animals. So this is more like a question that if we should be thinking about behavioral responses to make decisions about the management of many animals. And we have some examples here. This is the Mexican wolf, and many of the reintroduction attempts of this species have failed because mainly behavioral problems. So they still want to eat chicken, and they steal them from farms. So the farmer owners are not happy with that, and they kill them. So it's an interaction between the behavior of the animals that we are reintroducing and the society's behavior. And I know that genetics and population ecology are crucial. I am not saying that is the solution, but maybe we can start using our information to avoid these animals to fail in reproduction, competition, and finding other resources. So for this, I have a short story about this fish. This is Ogonoticus tequila. It is from a family that is called Godeide. They are native from Mexico City. And for many reasons, they are endangered. One of the main reasons are invasive species. So actually, this Ogonoticus tequila was extinct in the wild. So in 2015, there were rumors of attempting of reintroduction of this species. And for this, we made a little experiment with mesocosms, where we reintroduced this fish with some native species And with this fish that is invasive on the bottom, these come from the family Poecilidae. These fish are really similar to godates ecologically. The difference is their behavior. Poecilids are really aggressive. They can harass females from other species, and actually they can harm them. So when we introduce our fish with these exotic species, we found that they were less active. They actually were less feeding at a lower rate, and they were less interactive between them. So actually in that paper, we made some recommendations for the reintroduction plan, where we say that it is first very important to try to control the population of exotic species, because just looking at their behavior, they are likely to fade when they will be reintroduced. And actually this fish was reintroduced a couple of years ago. So finally, and this is just like, I take it as a cohesion between the first and the second. So it's about the individual variation for population conservation. And this goes more around after we are doing the captive breeding programs and the reintroduction programs. So we should be using behavior as an indicator of the environment. So this that the discussions go around the disadvantage of animal behavior. Actually, this paper says that it is an advantage, and I agree with that, because individual variation can tell us how is the environment actually, right? We are actually trying to conserve that individual variation, because ultimately those populations are made of many individuals. And what I found fascinating about behavior is that it's a trait or a group of traits that lie between genes and environment. So it's the first thing that animals can do or not do when there is a change in the environment. And I think that's why behavior is very interesting to study in this context of conservation. And another thing that the discussion goes around is that behavioral responses are changing all the time. So it will be very difficult to make these programs towards or around these traits. However, everything is changing all the time, right? So we have to keep track all the time. So it doesn't stop when we come up with a program for reintroduction, restoration, or for captive breeding. We have to keep tracking of the animals that we are using or we are trying to conserve. Yeah. And also the anthropogenic change is likely to keep going. So we also, I suggest at least, that we also need to study human society's behavior. And as many of my coworkers have said before, one way of doing it is actually education. So we should try to bring the society with us to come up with solutions that benefit the society and the biodiversity. So I want to thank my funding, my collaborators, and of course my students, because they do the hard work all the time. And I will be happy to take any questions. Thank you.
Thank you, Montserrat. That was a very interesting talk. We'd love to have some questions for you. There is a question, but it's in Spanish, so maybe someone can translate it for me. I don't know if I can
try, but I can't see it.
Can you open the chat?
Oh, it's because we are in a room, but maybe we can try.
Or maybe someone else.
Yeah,
so
we have our translator on the screen. It says, I have an idea in relationship with the content of pesticides presence in the products of free circulation in Mexico, and with the attempt of a law for economy. This point is considered under some legislation in Mexico or under some norm or residue law. You know, we have those laws. I am sure we have them. The problem is that Chlorpyrifos is not included in any norm that I know, or at least any law. So there is actually a group in Nayarit that is trying to push the Chlorpyrifos to be banned from Mexico. Because we have a lot of information. I am not the only one that has worked with this pesticide. There are many researchers that are doing it. So we are trying to push that. I hope we can do it soon.
I actually have a question for you.
Sure.
So I use biological indicators to monitor the health of mangroves and other coastal wetlands in the context of protection and specific and especially restoration to track biodiversity recovery. And so quite often, we use like the presence and absence of species that are expected in a community assemblage or in functional groups. So if species have persistence in an environment that has some level of pollution, how do we monitor changes in like their behavior and physiology, I guess, without having to get like full animal ethics approval, because that's quite difficult as a researcher. And if we're expecting sort of citizen scientists to monitor ecosystem health, is there a way that we can do it without having to sort of trap the animals? And
yes, actually, the experiment that we did with the mesocosms, we didn't catch them. So what we did was just stay there and observe them. And we were able to actually see that the native species was not coming to the top of the mesocosms. They were not feeding as much. And I think that's why I think that behavior is a good way of assessing that without going into the trouble of catching animals. And of course, we would need to catch them maybe for identification, because these fish specifically are really similar to each other. They are actually the same size, but we have some ways of identify them. So actually, Sogonaticus tequila has a line, a brightly yellow line on the tail. And yeah, I think behavior is a good option for doing it without disturbing much the system.
yeah, so there's a lot you can do by observation.
Exactly.
Okay, and a question by Elvia. How does climate change affect the behavior of animal populations?
How does the climate change affect? Sorry, what?
So how does climate change affect the behavior of animals or their populations?
Oh, climate change. Oh, well, climate change is another topic that I didn't touch, but I know that there's a lot of research around it. Actually, Brian works with a little bit of this in his lab and with the same species that I am working on, and it affects them. The main trait that we have found that is affected is aggressiveness. So the increment of the temperature actually makes animals more aggressive. And we think it's because of metabolism costs. That's what we think. And we have seen this in spiders. I know that there are some works in frogs and mainly invertebrates. But usually what happens is that the activity rates increase with climate change.
Okay. And she also asked, what are some of Mexico's emblematic species, I guess, charismatic species that have been subject of animal behavior studies?
Well, this actually, the Sogonaticus tequila, maybe it's not as charismatic a species, I would say, but it was like an emblematic species because it's Sogonaticus tequila. So it comes from the place where we produce tequila. So we have water bodies there, and I would say that's why people were so interested in this fish specifically, because it was endemic from this particular site. I wouldn't call Dryophytes ranicolor an emblematic species. We are more interested in, for example, axolotls and maybe birds, I would say. But yes, I mean, we can use these like as symbols, right, as banners to try to conserve the environment in its totality. So it has its advantages, I would say. Sorry, it's because you are here and the camera is here, so. I'm so sorry.
We're all doing very well. Online conferences are always challenging.
Yeah.
Thank you so much,
Thank you.
Montserrat. Now we're going to move to the discussion with Professor Hugh Possingham. And I'm not really sure how this is going to work, but I suggest that if you're able to maybe turn off your or turn on your cameras so that it can be a bit more interactive. And it would be great if people can, like unmute themselves and have a chat and ask questions. So I'll just introduce Hugh, and if he can. No, I can't see him yet. Oh, there you are. So Hugh is currently the Chief Counsellor of the newly created Australia's Biodiversity Council, and he's also the Chief Scientist of Accounting for Nature. And he's the former Chief Scientist of Queensland, as well as the Nature Conservancy, but he still works at the University of Queensland, and he was an Australian Research Council Laureate Fellow until the end of 2018. And he's published hundreds of papers, and he's supervised over 150 doctoral and postdoctoral researchers, and his research motivation is to secure the world's biological diversity. He co-developed the MarkSAN software for systematic conservation planning, which is considered the most significant contribution to conservation biology. So, thank you so much for participating in the discussion. And I mean, we can just talk about, if you've got questions for Hugh in general about, how we can facilitate collaboration between Mexico and Australia to advance conservation. Also, people have questions from previous presenters, we can chat about that.
Hi everybody, I'm getting a lot of feedback.
Maybe if everyone just puts their mute back on and then only turn it off when you're going to talk. Only turn it on when you're going to talk. Okay, thanks. Do you want to say anything, Hugh, to start off?
No, I'm sorry I was missing on the first 2 days, but I enjoyed the talks that I just heard. Maybe just a couple of quick things, and then happy to answer any questions. I think Evelyn gave me a couple of things to think about the importance of collaboration across countries, but also how do you get things done in the real world. Let me begin by acknowledging the traditional owners of where I sit, which is the Yagara and Turrbal people. So, and to pay respects to those traditional custodians of this land. And I think it's always important to reflect on the fact that First Nations Australians have been here for over 50,000 years, and the environment around us is entirely shaped by that. And people like myself with an entirely European heritage only turned up about 200 years ago. In fact, my relatives arrived in the 1850s. Relatively new and certainly relatively new on a global scale. I also think following Tatsuya's talk, it's always worth reflecting on privilege, and Valerie could mention some of the achievements in my life, but most of those achievements, 99% of them, are driven by the fact that I was born very, very, very privileged in every possible way. So it's always worth thinking about all your privileges, and we all have different ones. There's about 12 to 16 dimensions of privilege: education, gender, race, financial background, family stability, all of Maslow's pyramid. But I think Tatsuya's talk is just one dimension of privilege, which is language. There are other dimensions of privilege, and I think CBCS is really committed to trying to make sure that there is more equity in the world of conservation. So one thing I sort of wanted to briefly cover, and then happy to answer questions, I suppose. One is, what's the point of all this international collaboration? Why would we talk from Mexico to Australia? I think there's enormous values in that. And let me begin by saying that I did my PhD in the United Kingdom. I did postdoc in the United States. I spent a lot of time at Santa Barbara and at workshops, particularly in the United States. I've been to the United States over 50 times, and I worked there as the Nature Conservancy chief scientist. The benefits of me going physically to Santa Barbara for National Centre for Ecological Analysis and Synthesis workshops for a period of 10 to 15 years were immense. So Australia, although we have many privileges, the one minor disadvantage we have, we're sort of a long, long way from a lot of science. And as you know, 50% of conservation science is published out of the United States. I would hope in a few years' time that number will diminish, because the domination of the United States in conservation, I think, is something that we need to deal with, and it's a waning domination. But then if it's not the United States, it's the United Kingdom, it's European countries. So far away in Australia, which has a completely different ecology from anywhere in the rest of the planet, places covered in eucalypts and parrots and a whole heap of organisms that don't live anywhere else in the world and are not related to anything anywhere else in the world. It's, I think, very important that we make connections across countries and continents. And in many ways, Australia and Mexico have an enormous amount in common, far more than, say, Australia and the United Kingdom, yet so many Australians spend a lot of their research and collaborations with the United Kingdom. The United Kingdom is flat and green. It doesn't have a desert. It doesn't have a rainforest. Mexico and Australia go from deserts to rainforest. We're both mega diverse countries. We have all the challenges of distance and topography, and we have huge numbers of species. Many species we still don't know the names of, and many species we know nothing about the ecology of. So Australia, despite its privileged status as a very wealthy country, we just don't have enough conservation scientists and ecologists to work out what's going on, to be blunt. We really don't know what's going on. Yet the literature that we consume is largely European literature and North American literature. And in many ways, they solve their problems. If they want to go monitoring in England, they get on a bicycle. There are so many people in England, they can count every bird and every moth and every butterfly, and they can micromanage the environment. Mexico and Australia, we can't micromanage the environment. We have things like fire management, highly contentious issue. And I think what's exciting is that when you look at things like fire management in Australia, there are hundreds of fire managers. It's a highly contentious issue. How do you manage fire, particularly in the context of Indigenous management of fire for tens of thousands of years? But we're not going to learn a lot from the Germans, are we? Or the Swiss or the English about fire management. There's none of those ecosystems are anything like ours. But a lot of Mexican ecosystems are very much like ours, particularly the Mediterranean Mexican ecosystems and the subtropical Mexican ecosystems. I must admit, having been to many fire conferences, I don't know a lot about how fire is managed in Mexico. So I think there's many points. The reptile diversity, the United Kingdom has 6 reptiles. Mexico and Australia are 2 countries that have ridiculous reptile diversity. And the conservation of reptiles, as we heard from one of the speakers, is something that is we know very little about and is mainly ignored. And before I answer any questions, maybe I'll also say it's not just the ecology and the conservation, we have a lot to learn. I would encourage more and more movement of people, because although these Zoom talks and webinars are very important, when we do have resources at CBCS, we use them mainly for inviting people from overseas. So when we've had big centres, one year we had 30 different workshops with over 100 international visitors. So working out mechanisms to get people together face-to-face to tackle problems as a community, I think is very important. And at CBCS long ago, we also learned how to share. So the reason why the University of Queensland is in the top 10 universities in the world in biodiversity conservation by publication is because we share and we talk and we meet. Not because we're particularly smart, we share and we talk and we meet. And the other area I think that we can learn a lot from each other is policy. And this is something that I spend most of my time on now. It's policy, and actually things like rezoning marine protected areas, threatened species policy. But I can tell you the government bureaucrats do not move from country to country. In fact, Australian bureaucrats aren't really allowed to go overseas. So they can't learn about what's going on in Mexico or Colombia or South Africa about policy that works. So in fact, it's scientists, it's only scientists, because we do move so much and we read the international literature, we have the ability to transfer information and knowledge about policy and management to help the bureaucrats build better policy and management. To be very brief, the threatened species legislation in Australia is partly modelled on the US threatened species legislation, hasn't worked as well. Many countries have threatened species legislation. In general, the legislation can be quite good. Legislation to protect threatened species using offsets and other mechanisms and refusals. But in general, it hasn't been working. In the US, it works because in the US, there's third-party oversight of all threatened species issues, and they basically spend their life suing each other. So in the United States, the threatened species legislation only works because they spend billions of dollars in court with lawyers and judges. Now, I don't think Australia wants to do that, and I don't think Mexico wants to do that. So we have a common problem. How do you create threatened species legislation without adopting a US-style threatened species legislation, which is not tenable in almost any other country other than the United States? So I really say that as an example that there's a lot to be learned around policy and management issues and how we get politics to work for biodiversity conservation. And I'm certainly happy to answer any questions, if there are any questions.
Well, I think you've pretty much answered the questions I was going to ask you, which was like how collaboration can help to advance solutions in biodiversity conservation. So you spoke about it can help solutions in fire management. It can help in because we share a lot of the same ecosystems and diversity of flora and fauna groups. So it can help in reptile conservation, for example, and particularly in policy development by getting scientists to transfer knowledge to government officials, and then with threatened species legislation. But I had a question. So how can practitioners and researchers create impact in biodiversity conservation? So you spoke about sharing and talking and meeting as one way to create impact. Do you have any suggestions for other ways?
Yeah. Well, I think at the university you're at there, Gerardo Ceballos is one of the people who have had a huge impact on government policy. And I'm sure, I can see the audience. Who knows Gerardo? Who's met him? Ceballos. He writes incredible papers. Nobody's putting up their hand. Well, he's well worth talking to because he is a very influential person in Mexican conservation. And some of you may or may not have been taught by him. How does he get things done, and how do I get things done? To be blunt, you can work through the NGOs, which works okay. So we have a new NGO, the Biodiversity Council. I work with WWF, TNC, Conservation International, every single Australian NGO, and I help them. But I also make I have direct relationships with politicians. So the impacts that I've had on issues like land clearing, rezoning the Great Barrier Reef, largely come from personal relationships with politicians at a federal, state and local level. So I know that there's no science in that, and there's not even sensible politics in it. It's just take every possible opportunity to meet politicians and tell them what you think and what you know. Or as people often say in science, they say to me, Hugh, why doesn't anybody pay attention to scientists? It's because nobody reads scientific papers other than us. Nobody. Occasionally the public servants read them. But unless you're meeting face to face with politicians and bureaucrats, you won't have any impact on them. So what does that mean? It means you have to spend your life turning up. So turn up. So at various points in my career, when I've had a full-time academic job and a full teaching load, and often 20 PhD students simultaneously, I was spending 30 to 40 days of the year on government committees. 30 to 40 full days per year on government committees. Now I spend even more than that to volunteering my time to committees and advisory groups. Now you can't always do that all the time. So go and talk to your local council, go and talk to your state government, ask them where they get their information from. Every politician has to meet the people who ask them to meet. If you ask a politician to have a meeting and they are your local representatives, they have to say yes, and maybe you want to go as a group of 2 or 3 and ask them about their biodiversity policies, ask them about habitat destruction, ask them about threatened species, ask them what they're doing. And then that's the way to having impact. It's not what most scientists unfortunately do, but that's the way to get it done.
Great advice. There is a question in the chat, and I don't know if Alexi wants to actually say the question in person, or otherwise I can read it out.
I don't know if
Well,
this is working properly.
Yep, we can hear you.
Okay, well, in related to my question that I put in the chat, my line of study is related to the use of stable isotopes to study trophic ecology of predators in different systems. And well, I just got to this reunion. I really didn't know about until a friend of mine told me about this communication between Australia and Mexico. And I was wondering if in Australia, is there like anyone that I could contact in this case to apply this technique in the use of stable isotopes in trophic ecology? Because I'm currently finishing my master's and I'm interested in doing my PhD abroad. So yeah, that's more or less my question.
Yeah, that's a very specific question.
I know.
Steve Beisinger at Berkeley University is my one close colleague. That Berkeley in California, who I know has done a lot of stable isotope work. I think there are a few people working on stable isotopes. It's not a huge topic in Australian conservation. My question always is to anybody doing science and who cares about conservation, how will the science translate into outcomes on the ground? So, somebody like Valerie and Jonathan are actively involved in delivering science to management about, in case, how do you restore coastal wetlands? How do you protect and restore koala habitat? So the stable isotope work, I think, has been very interesting and very useful in conservation. I keep thinking about what does it mean in terms of policy and management on the ground. Australia is, remember, a very small country. I mean, it's very big, but it's very small. We only have 25 million people. So the one thing is that, unlike the United States and Europe, we don't really cover off on every topic. We are very strong in certain areas and we're quite weak in other areas in terms of conservation science. So I think the best thing is just to Google. I would say that over the years, I've had now, I think, 4 Mexican PhD students and master's students, and they've all been fabulous. There are points in time when it is a bit easier to get PhD scholarships in Australia. At the moment, it's a little bit tricky. The most important advice I have to anybody who's thinking of a PhD in Australia, yes, it's a great place to do conservation and ecology. Per capita, there's no stronger country in the world, maybe the Swedes or the Swiss, but there's an enormous amount of conservation science. 10% of conservation science comes out of Australia, and we're less than 1% of the world by far. But you do need a scholarship, and to get a scholarship in an Australian university now, in general, you need to have 1 or 2 peer-reviewed papers in the international literature. So you need 1 or 2 peer-reviewed papers to get a scholarship. Once you get a scholarship, your fees and costs are all covered. We don't work like the United States. In the United States and Europe, people get grants to support PhD students. We do that a little bit, but most of the time PhD students applies to universities, and then there's a competitive process. And once they get their scholarship and they get their stipend and they get their fee waiver, then they can work with anybody in that university. So it's not the same. PhD processes are definitely not the same as the United Kingdom or the United States or Mexico, in fact. Anyway, bottom line is, to make progress, like always, getting 1 or 2 papers out of a master's thesis or an undergraduate project is extremely valuable for your career progression.
Okay, thank you so much.
Okay, well, we're at time already. It's gone so quickly. So we're going to have to end. But Alexi, I know lots of people undertaking stable isotope analysis in coastal ecosystems. So just email me. I can let you know. But I just hand over to Evelyn because she just wants to say some thank yous.
Hello, everyone. Just to close this event, first I wanted to thank you to all the people that helped to make this event happening. And I would like to start for the project lead applicants and part of the organizing committee as well. So first of all, to Dr. Emilia Wenger, because without her, I wouldn't be here and I wouldn't have applied to this great call. Also to Dr. Cesar Zamora, because he is in Mexico coordinating all the work with the different departments in charge of the approvals and support to make this happen. To Dr. Hugo Perales and Aide Saldaña, because they were very supportive from the beginning. Also to Dr. Maria Arismendi and Dr. Ibrahim for their support and interest to go beyond just a conference. I would like to thank the rest of the organizing committee. As Jonathan Rhodes mentioned, Harmar has been an important piece in making this project happening. Also to Harris, Maricel, Julieta, Rhiannon, Miranda, and Anaka that were very supportive. All of them play an important part in delivering this project. And well, there are more people that is not listed here, but they were very helpful. Kate Donnelly on behalf of CBCAs, the UQ ITS team, helping us with approval for with the software and other things. Also to marketing and communication for helping us with the artwork for posters. And also the creation of the web page. To the finance team and Shadi Kafi from the Circular Economy Working Group at UQ for her initial guidance with this project. To the moderators, thank you so much, Valerie, for your great work moderating this session today, and also to Carlina and Corny that helped us the previous days. Thank you to all the speakers for their great talks, their time and interest in this event, and also to the audience for their questions and their engagement. And finally, I hope this virtual space can help to know what the work is done at each university around conservation, and hopefully this can trigger future collaborations. And in the face of climate change and biodiversity crisis, I do believe that joining efforts, collaborating and coordinating, it's key to be prepared for coming challenges and to be ready to address them. So thank you very much, everyone, for your time and for your participation. And that's all for me.
Okay, thank you, everyone. And please make sure to fill in the Google Sheet with if you're interested in collaborating, so we can share contact emails.
Yeah, thank you very much, everyone. Buenas tardes in Mexico. Good morning still in Australia. Have a good one.
Bye.
Thank you. Bye.
you.